Today's topic is going to be over factoring. Okay, to start this presentation, I have to share my screen because I like sharing my screen because I like to use animation. Okay, so let me start by sharing my screen. Okay, so let me start from the beginning. Okay, again, welcome to Friday Happy Hour. My name is Mr. Isasi, and I'll be presenting today the topic of factoring. Okay, I put the slide in here, guys, just so you know the important. How important it is to know how to factor. In the past semester, I had some students actually in my Calculus 1 class, and they didn't know how to factor that well. So that's why I want to bring the importance and the urgency on students that are majoring in math or engineering to know how to factor. So hopefully this workshop is going to give you an idea, how to factor and how important it is. For example, these are the courses that require factoring. They start with the NCBN, which is 0114, which goes along with the 0314, which leads to 1314. Then the NCBN 0124 and 0324, they lead to the 1324. Okay, now these, factoring is required on both of these majors. For example, you're going for business and accounting, you have to take 1324 and 1325. If you're going for, say, math, computer science, or engineering, you have to take 1314, 2412, Cal 1, Cal 2, Cal 3, linear algebra, and differential equations. All these courses require factoring, and I'm going to show you examples of each one. Okay. So, for example, what's the purpose of factoring? The purpose of factoring quadratic expressions is to eventually lead to a method of solving a quadratic equation. So, for example, this is a graph of the function y equals to negative x squared minus 2x plus 8. So the purpose is trying to find the x-intercepts, which are negative 4, 0 and 2, 0. These x-intercepts are also called x-intercepts, solutions, zeros, or roots. They all mean the same thing, finding the x-intercepts where the graph crosses the x-intercepts. Okay. For example, the equation y equals to negative x squared minus 2x plus 8, this is a graph, and here are the intercepts. But you have to know how to factor to actually find the intercepts, which are negative 4 and 2, which are right here, negative 4, 0 and 2, 0. Okay, now how do we apply this in real life? All these are examples of parabolas of quadratic equations. For example, a quadratic equation means it's like a loop, right? Like something like a loop like that, right? This is also an example. These are many, right? This is like a polynomial, but it has many quadratics. The arc of McDonald's, you see, it has two quadratics. And this is how you apply them in word problems in mathematics. You see, for example, this is a profit function, profit graph, and this is the maximum profit, and so forth. This is a maximum height that the bar reaches. And here is also, these are the intercepts here, right? Also here are the intercepts where the graph crosses the intercept. So this is what we're going to be looking at. But these are examples of real life examples of quadratic functions. Okay, now this is a handout that I came up with. Okay, when I was first teaching 0305, I went over the concepts for the students, and I thought they were ready because they thought they were ready too. But for some reason, more than half of the class didn't pass the exam on factoring. So I asked my students, hey, so what happened? He goes, no, Mr. I see too many steps, too many rules, and stuff like that. So that kind of encouraged me to come up with a factoring steps. So these are the factoring steps that if you follow, you should not go wrong, because at times, students might say, well, when do I stop? Well, you stop when there's nothing else to do here, guys. I'm going to show you examples of step 1, step 2. Step 2A is if you have 2 terms, if you have 3 terms, if you have 4 terms. So I'm going to go over examples and the concept for each one of these. Okay, now this I call the factor sheet, because when I actually teach courses, I want all students to feel welcome and not to feel left behind. For example, there's instructors that would not like for students to use this factor sheet, right? So it's all up to the instructor. but I like to reach the students that they don't know what factors are, because at times students actually come back to school at a later age, and they're taking like an upper level math course, and instructors, some instructors, they're not going to go back and explain what things are. Things that you should know by now. That's why this method, nobody gets left behind. So these are factors. For example, the factors how to get 12 is 1, 2, 3, 4, 6, and 12, right? All these are called factors. But this handout is what I give to my students. And if you want a copy, I can give you a copy of this handout. But anyway, this is what I'm going to go over, and this helps how to factor. These are the steps that were in that handout on the steps to factor. The first step is finding the GCF. What's the greatest common factor? In other words, what is the highest factor to factor out? And then step 2 is determine the number of terms. And then I put for note, make sure that terms are in order. If not, rewrite them in order from highest degree to smallest degree before continuing. And then step 2 is, step 2a is if it's 2 terms, it's either going to be perfect squares, which is x squared minus y squared, or x squared plus y squared, or perfect cubes, which is x cubed minus y cubed, and so forth. If it's 3 terms, it's either, I call this the easy factoring, or it's going to be the ax squared plus bx plus c. There's 2 ways to factor in this form. There's a trial and error, and also by grouping. I prefer grouping because this way I get to assist students that actually have a hard time with math, and by grouping it will be easier for them. Okay, and also if you have 4 terms, is by grouping. So let's start with some of the vocabulary. What's a quadratic expression? It's an expression involving square terms. Examples: x squared minus x minus 12 is an example of quadratic expression. Why? Because the highest power is 2. That means it's going to be a quadratic. Another example can be x squared minus 4. Another example can be negative x squared minus 4x minus 2, and so forth, right? But the highest power is going to be a 2. A degree of 2 is what a quadratic expression is. Okay, now what are factors? Factors are numbers that multiply together to get another number. For example, what are the factors of 12? How can we get 12? You see, these are all the combinations how to get 12. 1 times 12, 2 times 6, and 3 times 4. So the factors of 12 are 1, 2, 3, 4, 6, and 12. Okay. Example 2, what are the factors of 20? How can we get 20? 1 times 20, 2 times 10, and 4 times 5. So the factors of 20 are going to be 1, 2, 4, 5, 10, and 20. Okay. Another term that we got to know is called the greatest common factor, which means the GCF for short. The GCF of a set of numbers is the largest factor that all numbers share, or that all numbers have in common. Example 3, what is a GCF? Or so this is supposed to be of, okay guys, I put off for some reason, but it's supposed to be of 12 and 20. So the factors of 12 and 20, you see what factors do they have in common? The 1s, the 2s, and the 4s. So my GCF is going to be the highest factor that they have in common is going to be 4. Okay, it's going to be 4. There it is. Okay, now as I go through this workshop, since I'm sharing my screen, I don't have access to the chats or nothing like that, or if anybody has any questions. So if the participants have any questions, just raise your hand up, and the moderators will stop me, and then I can answer your questions right there and then. Okay, so please feel free to ask questions by going to the chat, or actually going to the mic and asking your questions, and I'll stop and explain whatever I'm doing. Okay, now how do we use a factor sheet? Okay, and I repeat this, some faculty will let you use this and some don't. For example, in my case, I let them use them, but not on the exams. This way, they know what factors are, and they know this also works as a calculator also. Okay, because according to the syllabus, if you're taking the NCBN 0324 or 1314, I believe you can use a scientific calculator. And if you're taking an upper level math class, you can use the graphing calculators. Okay, so this will work as a calculator. Let me show you how it works. So again, example 1, right? This is the one that we did earlier. What are the factors of 12, right? It was 1, 2, 3, 4, 6, and 12. The factors of 20, right, from the example 2 from the previous slide, it was 1, 2, 4, 5, 10, and 20. What's the GCF? Remember, it was 4. Okay, now here's how we use the factor sheet. Okay, how does the factor sheet work? So factors are 12, right? So we're going to go 12 here in the factor sheet. So I'm going to make it bigger over here. So these are the factors of 12, which is 1, 2, 3, 4, 2, 4, 6, and 12. Now the factors are 20, right? So the 20 is here. So then I'm going to bring it down here, right? So now you get to observe and see what's the highest factor they have in common. So the answer is 4. You see? That's how we use the factor sheet. And again, this works like a multiplication, like a calculator, for multiplying. So what's the greatest factor, or the greatest factor in common is 4. That's how we use the factor sheet. Okay, now here, guys, I'm going to explain every single step here and give you examples of each one. So let's start with step number 1, right, which is the GCF, greatest factor to factor out. So what's the GCF of 20 and 30, right? Find the factors of 20 and 30. So for 20, you guys can actually go to the factor sheet, right, and use it. Or at this stage, guys, in your education, you guys should know how to multiply. But like I said, at times students come back to school, right, with they don't know the multiplication that well. That's why the factor sheet is beneficial to them. So 2 times 10 and 4 times 5. So these are the factors of 20. 1, 2, 4, 5, 10, and 20. Now, how about 30? 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So these are the factors of 30. So what's the highest number they have in common, right? So they have 1, 2, 10 in common. So the highest factor, or the biggest factor, is going to be 10. So the answer is 10. Okay, now you can also find the GCF of variables, which are the letters in mathematics. Okay, but it's good to know the vocabulary. So these are called variables. So for example, for x squared, right, it's going to be x times x. For x cubed, it's going to be x times x times x. Okay, now how many x's do they have in common? They have in common 1, 2, right? So they have in common 2 x's. So that's going to be x times x. The answer is x squared. Okay, now here's an observation. Okay, if every term has the same variable, then the variable with the smallest degree is a GCF. So for example, here, x squared and x cubed, right? Which one's smaller? X squared, so that's my GCF. Okay, now, again, this is step number 1. Finding the greatest common factor. So here, guys, we're going to factor out the GCF of 30x squared plus 20x cubed. So this is the first step in factoring. What do the both terms have in common? Okay, between the 20 and the 30, right? We did it up here, right? Which was 10. For the variables, right? It was x squared. So that's my GCF. Now I'm going to factor it out. So if 10x squared is factored out, what's left? So here, guys, you can do it 2 ways. You can do division or multiplication. Here, you can ask yourself, what number times 10 will give me 30, right? So the answer is 3. We have x squared. We need x squared. Do we need more x's? No. So then the sign comes down. Now here, guys, I'm going to do a little bit different, right? So instead of multiplying, I'm going to divide. What's 20 divided by 10? The answer is 2. We have x squared, right? We need x cubed. So how many more x's do we need? Just 1. So this is what's left. Okay, so this is how you factor. This is how you factor completely this expression here. Okay. Okay, now factor out GCF, continue. Now, say you have an example of x times parentheses 2x minus 5, close parentheses, and then plus 2 parentheses 2x minus 5, close parentheses. These are only 2 terms, right? Only 2 terms, 1 and 2. So the GCF is going to be 2x minus 5. Because this is a binomial. With a parentheses, it means that this is together. You cannot separate it. Okay, it's called a binomial. But at times, guys, I call it a family in my class. Okay, this is a family. A family cannot be separated. That's why this is a family that they have in common, which are words that I use at times to reach students, because at times when you say it's a binomial, which is a correct term, some students might be over their head because they don't know what that is. Okay, so that's why I mentioned a family again, but this is called a binomial. They have the binomial, which is a GCF, will be 2x minus 5. So now, right? So I put it in red because that's what they have in common. So if 2x minus 5 is factored out, right? So if you take it out, what's left? The x plus 2. Okay, that's how you factor these types of expressions. So, so the answer is going to be 2x minus 5 times x plus 2. Okay, now this example is crucial for factoring polynomials with 4 terms. Okay, now this is 4 terms. Okay, I'm going to show you 4 terms, right? This is from the handout, which is the last step, 2c factor by grouping. Okay, now I'm going to show you 2 ways. Okay, 2 ways how to factor by grouping. I'm going to show you the way the textbook does it, and then I'm going to show you a different way, the way I modified it. Okay, and then you guys can use whatever method you want. Okay, now the book, they want you to factor in groups, right? This is a group 1, this is group 2. Okay, so I'm gonna put here group 1, right? So group 1 is what do they have in common? The factors of 2 are just 1 and 2. The factors of 8 is 1, 2, 4, and 8. So between 2 and 8, right? Between 2 and the 8, the GCF is going to be 2. Okay, now for the variables, right? We have x squared and we have x squared and x. So remember, guys, if they both have the same variable, it's going to be the variable with the smallest degree, which is x. So it's going to be the GCF of 2x squared plus 8x is going to be 2x. Okay, so if you factor 2x out, what's left? X plus 4. And you can always check your work by doing the distributive property. For example, if you multiply 2x times x, it's going to give you 2x squared. If you multiply 2x times 4, it's going to give you a positive 8x. So I know I'm on the right track. Now you do the same, right? You bring down the sign. Now you do the same thing for group 2. You have group 2, you have the 3 and the 12, right? That's what's here, 3 and the 12 for the coefficients. How can I get 3? Just 1 times 3. These are the factors of 3. How can I get 12? It's going to be 1 times 12, 2 times 6, and 3 times 4. So the factors of 12 are 1, 2, 3, 4, 6, and 12. What do they have in common? Are the 1s and the 3s. What's the highest factor? It's going to be 3. So the GCF of 3 and 12 is going to be 3. Now let's do the variables, right? Do they both have the x as a variable? No. So the GCF will just be 3. So I'm going to factor out the 3. So what's left is going to be x plus 4. And again, you can check by using the distributive property. 3 times x will be 3x. 3 times 4 will give you 12. So I know we're in the right track. Now this one here looks like the one that we did on the example on top. What do these two terms have in common? The x plus 4. What's left? The 2x plus 3. So this is my result. Okay. Okay, now I'm going to show you a different method that I modified from the book. It's almost the same thing, but I just modified it to make more sense. Okay, to some students. So step 2, determine the number of terms, right? So this one was over here at the bottom, right? So I'm going to start out with 2c, which is 4 terms by grouping. Okay. So now this is a way I'm going to modify it. Another example, we have 2x squared minus 5x plus 4x minus 10. So again, we only start with the first 2 terms. Factor by grouping. Find the GCF of the first 2 terms, which is 2x squared minus 5x. What do these 2 terms have in common? It's going to just be x. Okay. So I'm going to factor out the x. What's left? 2x minus 5, because x times 2x will give you 2x squared, and x times negative 5 will give you negative 5x. Now here's where I do the modification. You don't have to do it by grouping. You don't have to group the first 2 terms and the last and the third and the fourth term. What you put here, guys, just automatically put it over here. It's going to work. If it can be done by grouping, it's going to work every time. The sign, you bring it down. Now here you can ask yourself, because something has to go here, a number has to go here. You ask yourself, what number times 2 times 2x will give me 4x? So the answer is 2. Because 2 times 2x will give me 4x, and 2 times negative 5 will give me negative 10. So I know I'm in the right track. Now what's the GCF between these 2 terms? Will be the 2x minus 5. So if you factor it out, what's left? The x plus 2. Okay. And again, I modified a little from the textbook. The binomial that is left after factoring the GCF on the first 2 terms, right? This is the binomial that was left, will always be the same binomial on the right if it can be factored by grouping. So this is what it means. Whatever is left here, guys, from after you factor the x out, whatever is here is always going to be the same one over here on the right. Okay, that's a modified version. Okay, now let's do another one. Okay, now again, factor by grouping because it's 4 terms. So we factor the first 2 terms. What do they have in common? The GCF of 3x squared minus 6x. The answer will be 3x. So if I factor out the 3x, what's left is going to be x minus 2. Because 3x times x will give you 3x squared, and 3x times negative 2 will give us negative 6. And again, what's left on the left side, you put it on the right side, x minus 2. The sign comes down. One number times x will give me 7x. The answer is 7. And again, let's check the work. Negative 7 times x, negative 7x. Negative 7 times negative 2 will give me the positive 14. What's the GCF between those 2 terms? Is going to be x minus 2. So if you factor it out, what's left? The 3x minus 7. This is how you factor by grouping. And this is crucial when you're going to be factoring when you have 3 terms with a coefficient in front that's not a 1, which I'm going to explain later. Okay. So now, guys, we did this, right? So we went from 1, right? Step 1, we already did that. We did 2C. Now let's do 2A. Determine the number of terms, right? What happens if it's 2 terms? It's either going to be perfect squares, right, which would be x squared minus y squared. This is a difference of 2 squares, and there's no such thing as a sum, because if it's x squared plus y squared, it's going to be prime. What does that mean? If it's plus, it's prime, means it cannot be factored. Doing it this way, it cannot be factored. Okay, so let's do steps 2A. If 2 terms, right? These are perfect squares. All right, so again, I copied this from the steps to factor. Okay, now what are perfect squares, guys? These are perfect squares. What 2 numbers multiplied by themselves that will give me the x to the 4th? So this will be x squared times x squared will give me x to the 4th. That's why x to the 4th is a perfect square. Also x squared, because x times x will give me x squared. Also 1 is a perfect square because 1 times 1 will give me 1. Also 4, right? It will be 2 times 2 will give me 4, and so forth. Try to know as much of these as possible. Okay, at least from 1 to 100. Okay, now how does it work? If you have x squared minus 1, right, it's going to be x minus y, or x plus y, right? This is the formula here, guys, or the proof here. So it's going to be x minus 1, x plus 1. X squared minus 4 is going to give you x minus 2 and x plus 2. X squared minus 9 is going to be x minus 3, x plus 3. X squared minus 49, what would this one be? Can somebody put in the chat? What would it be? I'll give you guys like 5 to 10 seconds. Can somebody do that for me? And moderators, could you please let me know if it's right or wrong? Or if somebody put something in the chat? Anybody?
But Jesus got it right.
Okay. What you'll be right, x minus 7 and x plus 7. What will be x squared minus 81? Can somebody want to give it a try real quick?
We got
9 is coming in.
Yeah.
Okay, so it was right. So it was here, guys. I switch the signs. Does it matter? No. What matters is as long as you have the x and the 9, right? It will be the plus and the minus. So the order doesn't matter. Okay, now x squared minus 100 will give us x plus 10, right? Or x minus 10, or vice versa, right? But this is how you factor x squared minus 100. This was a little bit more challenging. Can somebody try that one? At times I would say in class, okay, for extra credit, and people right away try to, jump in, right? Can somebody give me this one?
5 minus x and 6 minus y.
You're close. Okay, how about this one here? How about 5x minus 6y and 5x plus 6y, because 25 is a perfect square and so is x squared, so that'll be 5x. And 36 is a perfect square, which would be 6, right? And so is y squared, so it'll be 6y. So 5x minus 6y and 5x plus 6y. But you were very, 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 very close. Okay, how about x squared plus 36? Can somebody give me that one? What do you guys think?
X plus 6.
Okay, and then what else?
The square.
But check this out.
Is
If
it
it's
is
plus,
x plus 6 and x plus 6
x minus 6, no, check this out.
minus
If it's plus, right, if it's plus here, what is it? It's prime. It cannot be
prime.
done. So why did I put this in here, guys? Because if it's plus, it's prime. Here's where a lot of students make a mistake. Just because they say they're right, both are perfect squares, they want to put x plus 6 is minus 6. So that's why, guys, I leave this, the rule here. If it's plus, it's going to be prime. Yeah, so every time it's plus, it's prime. You cannot factor it. Only when it's minus and there are two perfect squares. But good job anyway, okay? Okay, now how about x to the fourth minus 16? It's going to give us x squared minus 4 and x squared plus 4. Now, remember, x squared plus 4 is prime, but x squared minus 4 are two perfect squares. So this will be x minus 2, x plus 2, and the x squared plus 4, since it's prime, all we do is bring it down. That's all. So this is my answer. Okay, now guys, I think you guys had plenty of examples how to do perfect squares, and I believe in you guys that you guys will be able to do perfect squares from now on. It's not that complicated. Okay. Okay, now how about perfect cubes? Hey guys, the perfect cubes you will not see them really until you get to you see some in the 2013 and the 1325 course for the business and also for calculus 1, but you don't see them as often. But I just want to also include them because this way nothing of factoring gets left out. Okay, so the perfect cubes, this is called the difference of two perfect cubes, and this is called the sum of two perfect cubes. Okay, so let's see how they work. I call this 1 the difference and 2 the sum. These are called perfect cubes. Why? Because x to the 6 is the same thing as x squared times x squared times x squared, which means what three variables or what three numbers multiplied by themselves will give you the number over here or the variable to the power over here on the left. So for example, x cubed is the same thing as x times x times x. So that's a perfect cube, x cubed. How about 1? 1 is 1 times 1 times 1, right? Will give you 1 cube. Also 8, right? We multiply 2 times 2 times 2 3 times, right? By itself, it's going to give me 8. So 8 is a perfect cube. So is 27. So is 64. And so is 125. At least know these right here, guys. But there's plenty more. Okay, but this is really, most of the times, most textbooks go all the way to 125. Okay, maybe up to the sixth one, but at least know all the way to 5. So how does it work then? Okay, here's what I tell my students. Hey guys, first, which one is it? Is it 1 or 2? Is it the sum? I mean, difference or the sum, right? It's going to be the sum. So let's bring down the formula and put it here, right? There's a formula for the sum. That's a formula they're going to be using, which is formula number 2. Okay. Now we have to convert the x cubed plus 125 into two perfect cubes. So we should know, right, that x cubed is going to be x cubed, right? And the 125 is here is going to be 5 cubed. So let's rewrite it, x cubed plus 125 as x cubed plus 5 cubed. Now, let every x equal to x, let every y equal to 5, right? So now you're going to go to the formula. Boom. So every x is equal to x, every y is equal to 5. And then what's x squared will just be x squared. What's x times y? What's x times 5 will give you 5x. What's y squared? What's 5 squared? Right? Then we simplify it. It's going to be x plus 5 times x squared minus 5x plus 25, because 5 squared is 25. That's how these are examples of perfect cubes. Okay, let's do one more. Okay, again, these are the perfect cubes on the left. So we have 27x cubed minus 64y cubed. Again, which one is it? Is it 1 or 2? It's going to be number 1, right? The difference. So here, guys, let's do this. Is 27 a perfect cube? Yeah, it's going to be 3, right? 3 cubed is 27. And is 64 a perfect cube? Yeah, it's 4 cubed, right? So it's going to be, let x equal to 3x and let y be 4y, right? Because 3x cubed, it will give you 27x cubed, and 4y cubed will give you 64y cubed. So for every x, I'm going to put 3x. For every y, I'm going to put 4y. Okay. So what's x is going to be 3x. What's y is going to be 4y. What's x squared, right? We're going to put 3x here. What's x times y? Let's put x and let's put the y, right? Which is a 4y. And y squared will be 4y. Goes there. Right now, let's simplify, right? This will be 3x minus 4y. 3x squared will give you 9x squared. 3x times 4y will give you 12xy. And 4y, parentheses 4y to the second power will give you 16y squared. So this is my result. Let me go back. That's my result. Okay, now we already did the first step, the second step. Right, second step has 1, 2, 3 possible ways it can be. We already did the perfect squares. We already did the perfect cubes. Now comes 3 terms. Okay, if it's 3 terms. This I call it the easy factoring, guys. Okay. You might some students say, hey, Mr. Assi, but you call it easy, but it's easy for you because you're the instructor, right? So maybe that's a wrong terminology. Maybe I'll change it next time. But maybe if you can give me, or just like in class at times, after I explain this concept here, I ask the students, was it easy? And most of the times they tell me yes, it wasn't that hard. That's the feedback that I get. Okay, now I want to show you the modified version that I came up with. Okay, then I'm going to show you the way some instructors explain it, or at times the book explain it. But the first method I'm going to show you is how I explain it to my students. Okay, now these are the rules here, guys. Okay, you have x squared plus bx plus c. The c is called the constant term, and this is called my bx term. So I want you guys to always focus on the constant term. Okay, here we go. If the constant term c is positive, if c is positive, the signs are going to be the same. Here, these will be the same signs inside the binomials. If the constant term c is negative, you can have different signs. So there'll be different signs here on the binomials. Okay, let's do this. Okay, are the signs the same or different for the following examples? Hey guys, every time that I explain factoring, I always want the students to get the signs right, because getting the signs right is like half the battle, right? So once you get the signs right, at least you get the signs right. So let me show you how simple it is to get the signs right. So you always focus on the constant term, right? So you focus on the c here, guys. This is my constant term, and this is a sign of the constant term. So if it's positive, right, we go up here. If it's positive, same signs. Example 2, if it's negative, right, different signs. Example 3, if it's negative, right, again, different signs. Example 4, if it's positive, same signs. Okay, a common mistake that students make is they try to look at the signs here at both signs. That's why I always say to look at the constant term sign. And once the students, still keep looking at both signs, I cover this side of the expression so they can only see the plus 24 here, guys. This way, their eyes focus on the constant term. Okay, so if the signs are the same, it's going to be the sum of the factors that must equal to the bx term. Different signs is going to be the difference of the factors must equal to the bx term, right? Same for example 3, and it's going to be the sum of the factors on example 4. So once you get the signs right, you're halfway there. Okay, now let's do example number 1. Okay, so this is the way I teach it to my students. Okay, this one always comes down. The first sign, right? So we know the signs are the same, but then they're both going to be minus. Now the next thing is that you're going to get the factors of 24. How can I get 24? And again, if students are returning students, like non-transitional students, like say you've been out for a long time from school, you can always use a factor sheet, right? So that can help you to get the factors. Because at times students, they don't go in order and they miss some of the factors that will give you 24. But if you follow the factor sheet or else a calculator, right? But by this time you guys should know it by heart, right? Because you're already at this level in college. But I'm just assuming that some of you guys don't know them, so that's why I use a factor sheet or use a calculator. So how can I get 24? 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Right? So, and then this sign tells you, right, what we do here, right? If they're the same, it's going to be the sum. So we're going to add them. The item must be -10, right? Because this is negative, right? So they're both going to be, we're going to add them and they're going to keep the sign. So anyway, what's 24 plus 1? 25. What's 12 plus 2? 14. What's 8 plus 3? 11. What's 4 plus 6? It's going to give us 10. So where's the match? The match is 6 and 4, right? So I know that -6 minus 4 will give me my -10. So then to factor it, I'm going to put the 6 and the 4 there. That's how you factor this one here. Okay. And again, some of the steps that I use, I got the input from students because I always tell my students, if you guys know how to do things better than my way, let me know. And then we'll put it to the test with the other students. And if they vote that is easier than my way, then I use your way from now on and I give you credit. So I got this about bringing the sign down from a student. And I got this, what's a constant term, the sign will always be what you do here with the factors. Okay. And I'm going to abbreviate more. I mean, I'm going to elaborate more on when bringing the sign down, okay, later on this PowerPoint. For example, here's where I'm going to use this. Okay, again, you bring the sign down. We know they're going to be different signs, right? So there's going to be a positive here. Why? Because negative times a positive will give you the constant term. That's the reason why. What's next, right? We get the factors of 30. How can I get 30? 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Right? So we're going to subtract. So subtraction. The difference of two factors equal to the bx term. So what's 30 minus 1? 29. 15 minus 2? 13. 10 minus 3? 7. 6 minus 5? 1. So do we have the combination here? Yes. So we have 7, so it's going to be the 3 and the 10. So 10 and 3 is my match. So it'll be -10 plus 3, right, will give me the -7. So my 10 goes first. If you bring the sign down, guys, the bigger factor always goes first if you bring the sign down. Again, here's what I was told by a student. She mentioned, Mr. Isasi, you know what I do? I said, what? I always bring the sign down. I said, why? Because before I would say it's going to be minus plus or plus minus, it doesn't matter. But she came with the idea that if you bring the sign down, the biggest factor always goes first, because the rule is when you have subtraction, right? When you have different signs, the sign of the bx term determines the biggest factor. So for example, here, right, we know that 3 and 10 is my match. So the sign of the bx term, which is negative, must be the biggest factor, which is 10. If you bring the sign down, you don't have to worry about thinking about that. Just put the bigger number first. That's what I put here. The sign of the bx term determines the largest factor. If the sign of the bx term is brought down, then the largest factor always goes first. Okay. Example number 3. Again, right? So it's going to be different signs. We bring the sign down, so it's going to be plus and minus. So factors of 20. Hey guys, once I explain to my students, guys, after like 2 examples, we can get straight to the point. For example, here I'm going to get straight to the point. Right? These are the factors: 1 times 20, 2 times 10, and 4 times 5. Right? It's going to be subtraction, correct? It's going to be subtraction because it's minus. So it'll be 19, it'll be 8, and it'll be 1. What's a big, right? I know this is my combination 4 and 5, right? So the 5 goes first because you brought the sign down, and the 4 goes second. This is how you factor the x squared plus x minus 20. It'll be x plus 5 and x minus 4. Now, example 4, right? They're going to be same signs. So they're going to be plus and plus, right? How can I get 15? 1 times 15, 3 plus 5, right? Same signs. We're going to add them. So it'll be 16, and it'll be 8. What's my match, right? Is 8x, so my match will be 5 and 3. Okay? Okay, now I'm going to show you the way the book shows you, also other instructors show you. Okay? Example 2, again, this is example 2 in another way. They say, right? So they say that you get the factors of -30. How can we get -30? Again, they're going to be different signs, right? How can we get -30? -1 times 30. 1 times -30. negative 2 times 15, 2 times negative 15, negative 3 times 10, and 3 times negative 10, negative 5 times 6, and 5 times negative 6. All of these factors will give you negative 30. Okay, now here's, if you know exactly what you're doing, I mean, if you're doing it this way and you understand it, we'll do it this way. But most of the times when students have not been in school for a long time, they don't know how to add and subtract integers. I mean, because I know it by experience, right? I mean, I've had times when I teach some of the courses, there's students that haven't been in school like in 10, 15 years. They don't know how to do stuff like this. That's why I try to make it, I mean, simpler than this. But this is the way some instructors teach it. Also the book. But I also teach it this way, so that way the student has an option. What's negative 1 plus 30? 29. What's 1 minus 30? Negative 29, right? And so forth. Negative 2 plus 15 will give you 13. 2 minus 15 will give you negative 13. Negative 3 plus 10 will give you 7. 3 minus 10 will give you negative 7. Negative 5 plus 6 will give you 1. And 5 minus 6 will give you negative 1. Where's my match? Right? Negative 7. So this, my match will be the 3 and the negative 10. So that's how you factor using it this way. And again, I'm not saying what method to use, because what's good about EPCC is that as instructors, they give us the option, as long as we teach some material, right, that has to be taught, we have like a way that we can use our own methods, right? So I always try to give students like different options how to do things. This way, they can use whatever they want to use, okay? But as long as they know how to do it. And again, this is example number 3, right? Right, factors of 20 will give you negative 1 times 20, 1 times negative 20, right, and so forth. And then, right, you add them. So my match, right, is positive 1, so it's going to be negative 4 and 5. That's my match. So that's how you factor. And again, I'll show you 2 ways, so you guys can choose whatever is easier for you guys, okay? Okay, now we're done to the last, to 2b, which is factoring with the ax squared plus bx plus c. This means that there's a coefficient that's not 1, because this is a coefficient of 1, right? But you don't see the 1 there, right? This is something besides 1, like it can be 2, it can be a 3, it can be 4, I mean more than 1. So I'm going to show you how to factor the ax squared plus bx plus c by grouping. Okay, now there's 2 ways to factor in this form. There's by trial and error. That's the way I learned it. I mean, when I came back to school back about 20 years ago, 15 years ago, was by trial and error. But one thing, when I was doing my internship at Eldorado High School, they told me that they don't do it that way, that they do it by grouping. So after they mentioned that to me, I figured that I mean, I don't know how to do it that way. I mean, by grouping back then. But now this is easier. I mean, in my opinion, this is easier because it doesn't leave nobody out. Whatever level you're at, you'll be able to do it this way, because by trial and error, it takes a lot of you have to know your multiplications real well. You also have to know how to add, subtract integers real well, and it's a little bit time consuming. If you do it by grouping, you can never go wrong, right? So let me show you how it's done. First, I mean, the first thing you ask is, what do they have in common, right? So it's nothing, right? Then you go to the step 2, which is determine the number of terms, right? This is 3 terms, and this is by using this method here by grouping. The AC here, guys, multiply a times c means that you multiply the coefficient that has the x squared times a constant. So what's 3 times 10? 30. Now you get the factors of 30. How can we get 30? 1 times 30, 2 times 15, 3 times 10, 5 times 6, right? And that means, right, we're going to add them, right? What's plus here, we're going to add them. So the factors to get the bx term, which is negative 11, this will give us 31, 17, 13, and 11. Okay, now, you guys must be wondering, what in the world is this right here? The 3 terms, 4 terms, 2 terms, and factored. Hey guys, this is like the steps that, for example, here, right? We start with with 3 terms. Now my next step my next here has to have 4 terms, right? You always keep the ones on the ends. From the factors here is where we get the other 2 terms, right? So it's going to be positive x plus 5x gives me the 11x. So the positive 6x plus 5x, I'm going to replace the 11x. Now you see, now we have 4 terms. 1, 2, 3, 4. Now you do it by grouping. I believe I already explained how to do grouping with 4 terms, right? So by grouping, you're going to group the first 2 terms first. What do these 2 terms have in common? It's going to be the 3x. What's left? The x plus 2. And again, you always check your work before you move on to make sure that you're doing it right. So 3x times x will give you 3x squared. 3x times 2 will give you the positive 6. Now, what you put on the left of it, what was left after you factored out, you put it on the right. You bring the sign down, the plus. Now, one number times x will give you 5x. The answer is 5. And again, you check your work. 5 times x, 5x. 5 times 2 will give you the positive 10. So I know we're in the right track. So I went from 3 terms to 4 terms to 2 terms. Now comes my answer. What they have in common? The x plus 2. What's left? The 3x plus 5. So it's factored. And this is a way for the students to know and to get familiar how to do this are the steps, right? So you start with 3 terms, and then 4, and then 2, and then the answer. Let me do one more. We have 2x squared minus 3x minus 9. So again, we multiply the 2 times the 9 and give us 18, right? I know it's going to be negative 18, but don't worry about that. Just know 2 times 9 is 18. Factors of 18. 1 times 18, 2 times 9, and 3 times 6. Now this means, right, we're going to subtract them, right? Because it's negative here, we're going to subtract them. When you subtract them, the factors to get the bx term, which is negative 3x. So that'll be 17. That'll give me 7, and that'll give me 3. So I know this is my combination. So let's see how we're going to rewrite it. So negative 6x plus 3x gives me my negative 3x. So again, we start with 3 terms, right? The 2 terms on the ends, they stay how they are. The middle term is going to get replaced by these 2, by the factors here, which is negative 6x plus 3x. Then we group them in pairs, right? So we group the first 2 terms. What do they have in common? It's going to be the 2x. What's left? X minus 3. And again, let's check our work. 2x times x will give you the 2x squared. 2x times negative 3 will give me the negative 6. What was left on the left side, you put it on the right side. The sign comes down. One number times x will give me 3x. The answer is 3. And again, let's check our work. 3 times x will give you 3x. 3 times negative 3 will give us negative 9. So I know I'm on the right track. What do these 2 terms have in common? Will be the x minus 3. What's left? The 2x plus 3 factor. Okay, now. Okay, guys, these are the math courses. And in the past, I don't think I showed this last year, but right now, guys, there's an issue with factoring with some students actually that when they get to the say to the calculus courses or even higher, they don't know how to factor that well either. Okay, guys, that's why I want to show the importance it is on factoring, and here I'm going to show you examples where you're going to see them. For example, in Math 1324, right, section 1.7 is using quadratic equations. This is page 58. Use factoring to solve each equation, right? So you see all these is factoring. And all these, we already did them, right? This was 3 terms. This is when you have a coefficient of 1 in the first term, right? This was by grouping. This is the 2 perfect squares, right? All these, you see them in 1324. How about 1325, right? This is like also like calculus 1.
I'm sorry to interrupt. Can you go
Yes.
back to the previous example? Jesus is asking if it makes a difference to put the 3x first and then the 6x.
Oh, no, it doesn't. But let me go back.
Thank you.
Let me go back. I'm sorry about that. You in here?
I believe so.
It doesn't matter if you put the 3 first, it's going to be the positive 3x and then minus the 6x. It doesn't matter. Okay? If you want, stay afterwards and I can show you, or the tutors can show you why it doesn't matter. You get the same thing at the end. Because check this out. If you put the 3x here, right, the positive 3x, what does the 2x squared and the 3x have in common? It'll just be an x. What's left? The 2x plus 3, right? And then here's where you, I mean, if you did it that way, then the 2x plus 3 will be first and the x minus 3 will be second. It doesn't matter. But if you want more clarification, I'm going to say afterwards, and perhaps I can help you or show you, or a tutor can help you and show you. Okay, now guys, talking about that, I mean, Ruben, thank you that you reminded me about the student that had a question. Hey guys, this Sunday, during Sunday numbers, I will be showing students how to factor, here at Trans Mountain. Every first Sunday of the month, Sunday numbers is at Trans Mountain, room 1136. Every second Sunday of the month is at Valle Verde, room A1401. And the rest of the Sundays of the month, they're going to be online. Okay, this Sunday, during Sunday numbers, I'm going to show you guys how to factor in detail. If you guys struggle factoring, please show up. I promise that you have a better understanding how to factor. Everybody that comes when I do it face to face, everybody leaves much better than when they came in. And I'm going to show you guys how to factor in detail. And I'm not satisfied until you guys actually learn how to factor.
I'm sorry to interrupt, Mr. Isasi again. What time
Yes.
is the Sunday numbers?
Okay, now it's because I have them like in courses, but for this week it's like a special week. Why? Because from 9 to 10, I'm going to show everybody how to factor. So get there at 9 o'clock, from 9 to 10.
At 9 o'clock in the class?
Yes, in room 1136. It's a math lab here at Trans Mountain. Okay, but the original time for every Sunday is from 9 to 10. I do the 1314 and the 1324, and then from 10 to 11 I do the pre-cal, the pre-cal 2, and then from 11 to 12 I do all the calculus, including the 1325. And Mrs. Sassi, my wife, she does the remedial courses. She does the NCBNs. She also prepares students for the TSI test and also for the TEAS test for the people going for the nursing program. We all do that. I mean, we do all that online and also face to face. Okay. Okay, now guys, but going back to these, you see these, you're gonna see them again, factoring. You see these are limits for calculus 1 and also for the 1325 course. You see, you have to know how to factor. You see, this is 1314, finding the zeros of a function, algebraic, page 56, right? All this is finding the zeros. You have to know how to factor. You see, these are 4 terms here, right? 4 terms, you do it by grouping. And these are also 2412, right? You use trig. These are trigonometry. This, like for example, this example here, number 17 is like 4x squared minus 1. You see 2 perfect squares. For example, this one here, number 21, right? What's my GCF? My GCF is x. What's left? X squared minus 1. Then you factor by perfect squares. So all these courses, guys, require factoring. And like I said, in the past, I never show you where you use them, guys, but to me it's urgent because I'm finding out that many students, they don't know how to factor when they get to the upper level courses, guys. And believe me or not, guys, if you don't know how to factor, you're not going to pass those courses. So that's why I'm showing you all this, guys, just so you know how important it is. This is calculus 1, finding the critical numbers and intervals of increasing, decreasing. And also calculus 2, finding the area between 2 curves. And also differential equations or linear algebra differential equations, finding the eigenvalues. You see, you have to know how to factor. Okay, guys, let me go back. Let's see, we're done with this PowerPoint.
Mr. Isasi, what room number did you say?
Yvette, for at Trans Mountain, it's every first Sunday of the month is room 1136.
Okay.
And the second Sunday of the month, Yvette, is going to be at BV at the Student Support Services program, which is room A1401.
Thank you, Mr. Isasi.
Oh, you're welcome. Hey guys, thank you for showing up. Okay, I really appreciate you guys showing up and asking for help. Okay, and I hope this presentation is going to be beneficial for you guys trying to understand how to factor a little bit much better. Thank you.
So next week we will be meeting to Most of you will be taking exam 1 next week, especially if you're taking online classes. The lecture classes might be a little behind, but either way, next week we'll be doing the exam 1 reviews. Thank you guys for joining us every Friday, and have a good weekend. There's tutors here in case you have questions or you need additional help.